Okay, so our last topic is graphing the rational functions, sort of putting everything together. Typically, again, we're going to start with factoring everything we can. Before we do that, I like to identify the horizontal asymptote. The reason I like to do that initially is because if your function especially is in standard form, as this function is, then we can just quickly compare the degree of the numerator and the degree of the denominator. As Mr. McGivney told you, there's three possible scenarios. In this case, the degree is tied, and so therefore the horizontal asymptote will be the ratio of the leading coefficient. So in this case, y equals 2 over 1 or y equals 2 will be our horizontal asymptote. So I know that there's going to be a horizontal line that as the curve approaches positive and negative infinity, it will approach that line but never actually touch it. Okay, so now I've identified my horizontal asymptote. I'm ready to go ahead and factor. So in the numerator, I can pull out the 2, and I'm left with x squared plus 5x plus 6. And in the denominator, I'll go ahead and use sum product factoring, and that's x plus 2 times x plus 1. Okay, finishing up the numerator, I'll have 2 times x plus 3 times x plus 2 all over x plus 2 times x plus 1. Now, once we've got the expression factored, we can go ahead and identify the discontinuities by looking at the factors in the denominator. And so we can see that there's some form of discontinuity where x equals negative 2 and x equals positive 1, or excuse me, negative 1, the factor being x plus 1. So we have to identify what type of discontinuities there are. I noticed that the factor x plus 2, which led to the discontinuity at negative 2, that cancels out. So that's a removable discontinuity or a hole. So I know there's going to be a hole at negative 2. I noticed that the factor x plus 1, which corresponds to the discontinuity x equals negative 1, does not cancel. It's left over in my function. And so since it's left over in the denominator, that's going to correspond to a vertical asymptote. So I know there's a vertical asymptote where x equals negative 1. Now, I need to go back and find the y-coordinate of the hole. So in order to find the y-coordinate of the hole, we're going to plug in that value into the simplified function. So I'll have 2 times negative 2 plus 3 is 1 over negative 2 plus 1 is negative 1. And so this will tell me that there's a hole at negative 2 comma negative 2. So I'm going to go ahead and plot those features on the graph. Vertical asymptote where x equals negative 1. Draw in my dashed vertical line, label it, x equals negative 1. My hole is at negative 2 comma negative 2, so I'm going to plot that right down here. Use an open circle for that to represent the hole. Now let's find our x-intercepts. If you remember, to find the x-intercept, we set the simplified numerator equal to 0 and solve. And so if we divide by 2 and subtract 3, we'll find that x equals negative 3. And so therefore there's an x-intercept at negative 3 comma 0. So I can go ahead and plot that, and I can use a closed-in, filled-in circle for the x-intercept because it does exist on the graph. Finally, for the y-intercept, I'm going to plug in 0 in for x and solve. It doesn't matter if you do that in the simplified form or the original form. Either way, you'll find that when you plug in 0 for x and solve for y, you'll find that the y-intercept is at 0 comma 6. So we'll go ahead and plot that there. Okay, so now I've got to fill in a couple other points on my graph. What I like to do is pick a couple values, or make sure I have a couple values represented to the left of any asymptotes, to the right of any asymptotes. So we've got the vertical asymptote of negative 1. So I'm going to pick another. I've already got 2 points to the left there, the whole being 1 and the x-intercept being the other. So I'm going to plug in negative 4. And I plug in negative 4. And again, you can do that in the original function or the simplified function. I like to put the function into the calculator. I put the simplified function into the calculator. Just as a hint, remember you've got to put the entire numerator and the entire denominator in parentheses. So when we plug in negative 4, I'm going to get 0.67 repeating, or that's negative 4 comma 2/3. So if I have negative 4, 2/3 is right about there. Okay, so there's an additional point. If I plug in some points to the right, maybe I'll plug in, I already have 1 over there, so I'll plug in 1 and 2 in for x, and I'm going to get 4. And then if I plug in 2, it looks like I'm going to get 3 1/3, so it's 10/3. So I go ahead and plot those. And so 1 comma 4 would be, say, right about here, and 2 comma 3 1/3 would be right about there. I can look at the graph on my calculator to get a better sense, but you can kind of tell based upon the points that we have here what this curve is going to look like and how the asymptotes are going to influence it. Don't forget to skip over your hole. We don't want to sort of draw the curve through that point, or that missing point, I should say. And there's the upper part of my curve, and we notice that they never touch, they approach but never touch the horizontal and vertical asymptotes. Okay, let's move on to number 10. So number 10, just be careful, not quite in standard form, because notice that these sort of first two terms are switched. And so when I go to identify my horizontal asymptote here, I'm really considering that the degree of the numerator is degree 2 and the degree of the denominator is degree 3. And so therefore the degree is larger in the denominator. If you remember from Mr. McGivney's video, that means there's a horizontal asymptote where y equals 0. So I'm going to write along the x-axis. We know there's going to be a horizontal asymptote. So I'll draw that in. Okay, and the equation of that asymptote is going to be y equals 0. Okay, so let's start factoring up. I'm going to go ahead and I'm going to factor out a negative x from the numerator, which will leave me with an x minus 3. And in the denominator, I'm going to take out an x, and that'll leave me x squared minus 9, which can factor as x plus 3 times x minus 3. Okay, so now discontinuities where x equals 0, where x equals negative 3, and where x equals positive 3. And so we know we're going to have three features on the graph being either holes or vertical asymptotes, so let's identify what those are. All right, I notice that the x cancels out, so therefore there's going to be a hole where x equals 0. I notice that the x minus 3's cancel out, so I know that there's going to be a hole where x equals 3. And I notice that the x plus 3 does not cancel out, and so therefore I know there's going to be a vertical asymptote where x equals negative 3. Okay, let's find the y coordinates of those holes by plugging in 0 first into our simplified function, and we're going to get negative 1/3. And if we plug in 3, we'll get negative 1/6. So my coordinates of my holes is 0, negative 1/3 would be right about there. 3, negative 1/6 would be right about here. And I've got a vertical asymptote where x equals negative 3. So I'm going to draw that in, again, dashed vertical line. And I'll label that x equals negative 3. Okay, let's move on to our x-intercepts. If I set the simplified function equal to 0, negative 1 equals 0 doesn't make sense, so therefore there's no x-intercepts. And the other piece to think about here, we notice that there was a horizontal asymptote where y equals 0, so therefore there's not going to be an x-intercept, so there is none there. For y-intercept, I plug 0 into, again, either the original or the simplified version, and I'm going to get 0, negative 1/3, but note that that was already a hole, so it can't take on both. So since it's a restricted value on the graph, it's a discontinuity, there is no y-intercept in this case either. So let me fill in my table of values. Again, I'll pick a couple values to the right and a couple values to the left. I already have 2 values to the right of the vertical asymptote, so I'm going to pick one more to the right of that. Let's say I'll pick negative 1 for x, and I'll pick a couple values to the left, so I'm going to pick negative 4, negative 5, and negative 6, and I'll go ahead and plug those values in. So if I plug in negative 1, that'll give me negative 1 over 2, so negative 1/2. If I plug in negative 4, I'll get positive 1. If I plug in negative 5, I'll get 1/2, and negative 6 will yield 1/3. So let's go ahead and plot those. Negative 1, negative 1/2 will be right about there. Negative 4, 1 is here, there, and there. Okay, and again, if you plug this into your calculator, make sure the entire numerator and entire denominator are in parentheses, and will look like this. Okay, this hole should be a little bit higher up than the previous ones. Let me fix that up. Okay, let's make that a little bit higher up so it's a little bit more realistic. And then on the left side of my vertical asymptote, we can see that it curves down here. Okay, and it'll approach those asymptotes but never touch. Okay, Very good. Let's move on to the last example, number 11. Okay, again, I'm going to start with my horizontal asymptote, comparing the degree in the numerator and the denominator. I see that the degree is larger in the numerator, and so therefore I know that there is no horizontal asymptote. Whenever we have a higher degree in the numerator than we do in the denominator, the horizontal asymptote does not exist. I can factor the numerator as x minus 6 times x plus 5. The denominator nicely is already factored for us, okay, x plus 5. So I know there's a discontinuity where x equals negative 5. Now, because I can cancel out that factor, I know that that discontinuity is a hole. So I know that there's a hole where x equals negative 5. Now, if there is a hole where x equals negative 5, and that's the only discontinuity, that means there is no vertical asymptote. So I'll get rid of those. Now, to find the y-coordinate of the hole, we'll plug negative 5 into the simplified function, and that hole will be at negative 5 comma negative 11. For x-intercepts, I'm going to set my simplified numerator equal to 0 and solve, and I find that x equals 6, and so therefore there's an x-intercept at 6 comma 0, and y-intercept, I plug in 0 for x and solve, and I find that there is a y-intercept at 0 comma negative 6. Now, I want to go back and take a look at that simplified function, f of x equals x minus 6. We should recognize that. That's a linear function. Okay, so we're going to go ahead and graph this linear function. We know that there's a hole at negative 5 comma negative 11. So there, I know I've got an y-intercept of 0, negative 6. So that's there. I've got an x-intercept of 6 comma 0, so that's there. And I could draw my curve in. And again, not affected by any vertical or horizontal asymptotes. It's simply just a straight line. So not really any need to fill in our table of values there. Okay, so there's 3 graphing examples. You'll have some opportunities to speak with your teacher today if you have any other questions on the review. Good luck, guys.